no, it's not. It's not this. Still in November, and sometimes I do write 19 instead of 20. Okay, so let's pick a function. It can be polynomial, it can be rational, it can be radical. And then find the derivative using the limit of the difference quotient. Now, do you have any questions about the test? Anything that you want to go over from the test?
I think we already went over. I think we went over on Monday the questions I have.
Okay, so here's a question I have for you.
Okay.
For E, why didn't you check?
We talked about that. I didn't even think.
You have to.
Yeah, I know.
At all times, you must check that the function is defined.
And especially when the next one was the one that I said, like, oh, that's zero.
Right.
And then I'm like, oh, that one's zero. I should have gone and checked for all the other exceptions.
Right.
But
yes,
yeah.
if the function is not continuous, the fundamental theorem of calculus cannot be applied. Okay.
So I looked at it, like, got zero on this one. So from him, he's like, oh yeah, this is this. I'm like, ah, crap.
Yeah, I saw. Why can I compute
Yeah,
this? Why can I compute this? Wait a minute.
Okay, anything else? Anything else from the test, or we go back and we we look at a function?
Was the solutions to the test?
Yes,
Okay.
I did. Yes, but if you have some questions, I'll be more than happy to answer. Okay, let's come up with a function. Any function you want then.
So 3x squared minus 4 over the square root of.
Oh no, we can't do
Oh,
that.
we can't do that? Oh,
It's way too. It takes us 5 minutes to do the derivative with using the differentiation rules. But we can have x plus 1, for example, or x squared plus 1. That we can. But the square root of the denominator would take like 3 days. Okay, so we want to find f prime of x, and there is only one definition, which is limit sh approaches 0 from f of x plus h minus f of x divided by h. Now,
We've done this in a long time.
yeah, it will take us a while, because when I plug in x plus h in here, it's going to be torture, because it's going to be a binomial squared, which is 3 terms, a binomial squared, which is 3 terms. Do you want to change the function, or you want still this one? I'm fine with it. You still want this one?
I'm
Okay, very good. Okay, I have enough paper. F of x plus h is.
Luckily, it's just x squared, and not like the 2 to the third or anything, because that would be.
Good. Is this okay so far? I'm working on this piece a little bit to see if I can simplify it, because I will have to eventually. Okay? So I'm just working on this piece for a moment. So this will be 3x squared plus 6xh plus 3h squared minus 4 over x squared plus 2xh plus h squared plus 1. Is this okay so far? Okay, so now I'll put it in. So because I'm lazy, I'm going to do this. So you know this continues here. So limit sh approaches 0. And now 3x squared plus 6xh plus 3h squared minus 4 divided by x squared plus 2xh plus h squared plus 1 minus 3x squared minus 4 over x squared plus 1. It's great that you are admiring and nobody writes anything but me. That's okay.
What did I focus, and then I'll go back and I'll write it all down later.
Very good. So let's focus then.
Now I have to.
So now this one needs to be multiplied by x squared plus 1. And this one needs to be multiplied by all this. And the least common denominator will be x squared plus 1, x squared plus 2xh plus h squared plus 1. Of course, I already flipped because I want to write ones.
Right.
Okay, so this is x squared plus 2xh plus h squared plus 1. Okay, x squared with all these. 3x to the 4th plus 6x cubed h plus 3x squared h squared minus 4x squared plus 3x squared plus 6xh plus 3h squared minus 4. As I said, I have enough paper. Now, minus. I have to write
Right.
somewhere here. Minus 3x to the 4th minus 6x cubed h minus 3x squared h squared and minus 3x squared. Now with minus 4, but this will kill the negatives. So plus 4x squared plus 8xh plus 4h squared and plus 4. And now I hope that a lot will go away. I no longer have any color pencils. They're gone. They dried up.
I have a bunch of colors.
If I can get one. I do have one. So, first of all terms without h must go away. So, here's one, here's the other. At least those with more, of course, but at least those. And I'm hoping that something still stays in there because otherwise that's a problem too. Oh, thank you.
No problem.
Thank you. Wow, that's neat. Okay, so a 6xh with an 8xh, a 3h squared with a 4h squared, and I don't see anything else. So 1, 2, 3, 4, so 8 here. 1, 2, 3, 4, and 8 here. Yeah, I have 16 terms. Okay, so then finally, I have, this is so neat, it's green. So limit, it's red.
Oh.
Okay.
I've got a blue if you want blue.
No, that's okay. No, I just wanted to see what.
Oh, okay.
So limit as h approaches 0. This is 16. This is 14, and this is 7. But I have to factor out an h. So 14x plus 7h, everything divided by h, x squared plus 1, x squared plus 2xh plus h squared plus 1. Correct? These two go away, 1 and 1, and now h approaches 0. These terms are gone because h approaches 0. So then the numerator is 14x, and the denominator is x squared plus 1 times x squared plus 1, which is x squared plus 1 squared. Of course, now I have a tool that allows me to find the derivative of this in a blink, sort of. So the top prime is 6x times x squared plus 1 minus 3x squared minus 4 times the denominator prime over the denominator squared. I would factor out 2x. So I have a 3 left here. 3x squared plus 3. This is gone. Minus 3x squared but plus 4 over x squared plus 1 squared. These are gone. This is 7 times 2 is 14 over x squared plus 1 squared. And I know now that that is correct.
But we still gotta do it the long way.
Yes, just to remember that
Right.
the derivative is actually a limit of the the derivative is, first of all, the slope of a tangent line to a point, which is really determined by the limit of the slope of the secant line, which eventually changes into the tangent line. So this is the slope of the secant line.
Right.
And the limit of the slope of the secant line is the slope of the tangent line. But now, since this is a function, it will give us the slope of the tangent line at any point on the graph of f of x. Just tell me what x is, I'll plug it in, and I'll give you the slope. If you say 0, I'll say 0. If you say 1, I'll say 14 over 4. If you say 2, I'll say 28 over 9. And I can continue forever. Okay, anything else that you can think of right away?
Oh yeah, mean value theorem?
Yes. I mean value theorem is in chapter 3. So let's go to, actually it's in chapter 4, I'm sorry. Okay, so let's say problem 10 on page 289. And we have f of x, which is x cubed minus 3x plus 2, and the interval is -2, 2. Verify that the function satisfies the hypothesis of the mean value theorem on the given interval. Then find all numbers c that satisfy the condition. The conclusion, I'm sorry, of the mean value theorem.
It is continuous.
Very good. So number 1, f is continuous as a poly on -2, 2, and 2, f is differentiable as a poly on -2, 2.
So why is it that continuous has brackets and differentiable has parentheses?
Okay. The requirement is
At all points. Yeah.
right.
Okay.
It doesn't matter when it comes to continuity, because in other words, the function is continuous everywhere, including at the points, the end points from the left and from the right, of course. But the function is not required to be differentiable at those points.
Okay.
It may or may not be differentiable at those points. The theorem still holds, because the point will never be an end point.
Okay.
Anyway, very good. So then, if that happens and it's true, then there exists c in the interval -2, 2, such that f prime of c equals f of b minus f of a over b minus a. Okay, so f of b is, when this is a, this is b, I have to find f of -2, which will be this, and f of 2, which will be this. So -8 plus 6 plus 2, right? -2, -8 plus 6 plus 2. And then 8 minus 6 plus 2 will be 4. So and f prime of x is 3x squared minus 3. So therefore, f prime of c is 3c squared minus 3. 3c squared minus 3 equals 4 minus 0 divided by 2 minus -2. So this will be 3c squared minus 3 equals 1, or 3c squared equals 4, c squared equals 4/3. Take the square root. I think you had this problem on your test. C equals plus or minus 2 over the square root of 3. So now I have to verify that they are here. And if one is here, then the other one will be. So both solutions are in there. So if you grab your calculators and you divide 2 by the square root of 3, I get 1.15 roughly, and the other one is negative 1.15. Both are in that interval. Limits of all sorts. I think we did some limits last time. Logarithmic differentiation.
Yeah, that wouldn't hurt to look at.
Okay, logarithmic differentiation, very good. Let's make one up. Oh, yes, you can.
Oh.
It's a function raised to a function. There is no
Oh,
rule.
Yeah, that's true.
So let's say y equals whatever to raise to whatever.
So it's like x squared minus 1 in parentheses raised to x minus 2?
Yeah,
Does that work?
yes,
Okay.
perfect. So then I have natural log y equals x minus 2 quantity natural log x squared minus 1. I differentiate the left-hand side as 1 over y times dy over dx. And now I differentiate the product. The first function prime is 1, natural log x squared minus 1, plus x minus 2 times the second function prime, which is 1 over x squared minus 1 multiplied by 2x. All I have to do is multiply both sides by y. I'm not required to do anything else.
By y using
This one, by the function itself.
okay.
Yeah. So then I have dy over dx equals y, which is x squared minus 1 raised to x minus 2. And this is natural log x squared minus 1 plus 2x quantity x minus 2 over x squared minus 1. And this is it. Again, as I said, limits, graphing a piecewise defined function, limits that require to rationalize, limits that now you know L'Hopital's rule, you can always apply it when it's applicable. When is L'Hopital's rule applicable?
And 0, 0,
0 over 0 and,
infinity.
right?
And we always know we can play with it to make it 0 over 0.
Right.
Make it infinity.
Right. Right, right.
Which is cheating. But
Well, you can, I wouldn't say that,
but
but
it's legal by the rules of math,
absolutely, absolutely legal. Algebraic manipulations are always allowed, as long as they are legitimate.
Can we back up piecewise?
Yes, yes. Good. So yes, for example, we did this before. If you don't want to do this problem, we can choose another. I'm going to write it. Don't write it yet. Nobody's writing anything anyway. Except Sarah. So we did this problem before, but if you don't want to, oh, you wanted to graph. I'm sorry.
We can do this.
We could do this and also graph. Okay, I found the graph also. We're going to do both. So on page, both are on page 108. So 50, we have g of x, x for x less than 1, 3 for x equals 1, 2 minus x squared for this, and x minus 3 for this. Evaluate each of the following, sketch the graph, and then answer some questions. So which one would you like to start with?
That's not with the first one.
Okay, very good. So a problem like this, if you remember, if you look carefully at test 1, you will find a problem like this, in which you're asked to simplify it fully without absolute value, and then find the limit. Okay, ready? I have to start with the absolute value of x, which has two options.
It's x, as long as x is greater than or equal to 0.
Or
negative x, if x is less than 0.
right, but now, so far, I built this. Now I want to build this. That's my second step. So for that, I have to write 1 over the absolute value of x. And now there are two options, but I have to be careful now because this is in the denominator. This was defined at 0, but this one is not defined at 0.
Right, so now it's just 1 over x if x is greater than 0.
Oh, I'm sorry, yes.
Negative 1 over x if x is less than 0.
Right. Now I'm ready to build this whole thing.
And since it's 0 from the right.
Right, but I still have to finish it.
Okay.
You're right.
Okay.
You're right. So then I have the first option is 1 over x minus 1 over x, which is 0 for x greater than 0. The second option is 1 over x minus 1 over x, which is 2 over x for x less than 0. Now I can come back to this. 0 from the right is this. So this is basically the limit as x approaches 0 from the right from 0, and the answer is 0. Any questions? Okay, now let's graph all this and then answer some questions. Is that okay? Okay. So this is 50. By looking at these I can rewrite the first one as an interval between negative infinity and 1. Would you agree? I can write the third one as the interval 1 to 2 with a bracket. And I can write the last one as 2 to infinity. Now looking at this carefully, including x equals 1, I would like you to identify the domain. This is the first step I have to perform. I have to identify the domain.
Negative, oh, yeah, everything.
Yes. Now the next step, I recommend this method. Of course, you can choose any method you like. I will definitely have to have 0, 1, and 2. 0 is always in the chart. 1 and 2. Now under 1, I will have 3 different things. I will have a left, I will have a right, and I will also have a middle. But under 2, I will have a bracket to the left and a parenthesis touching to the right. Here, these two parentheses cannot touch because there is a number in the middle. Now, I know that this is overkill, but I will write for myself right here under my nose that for x less than 0, I have to use x. When x is 1, I have to have 3. And I'll put it right here in the middle. Between 1 and 2, I am using 2 minus x squared. And between 2 and infinity, I have to use x minus 3. Again, you don't have to do this, but for me it's easier. Instead of going back a page, I have it right here in front of me. Use it if you like it. Okay, so the left-hand side is a linear function. 0 gives us 0, and 1 gives us 1, and that's all I need. Now the middle part is a quadratic function, which has a negative leading coefficient, which will have a maximum. Negative leading coefficient, maximum parabola. Okay, when I plug in 1, I have 1. When I plug in 2, I have 2 minus 4, which is negative 2. Would you agree so far?
Yeah.
Now, when I plug in 2 on the linear function on the right-hand side, I get -1. And when I plug in 3, I get 0. Are you okay with this?
Yes.
Okay. Now I'm ready to graph.
I like that pen.
Which one? This one?
Oh, well,
The green?
yeah, the other one, but with the sharp.
This one? The Sharpie?
Oh, the one that was writing, the one writing in blue, or the one writing in black? That was one that you were writing earlier. That had a.
This one? The fountain pen?
Yes, my bad.
Okay, thank you. So 0, 0. 1, 1, which has to be an open point. And I am finished with the left-hand side, which is the x. 1, 3. I fill it in at 1, 3. And on the other side, in the middle, I should say, 1, 1, 2, -2, full point. And I know that this is a function opening downward, quadratic, having a maximum. So from 1, 1 down to -2. Now 2, -1 is this point here. It doesn't touch. I'm sorry. It shows like it is touching, but it's not touching. So 2, -1, and then 3, 0. This is the graph of the function. Can anyone identify the range for this? Of course, everything. Excellent. Good. So now I have to answer a couple of questions. The limit of g of x as x approaches 1 from the left. I don't need a graph for that. Limit of g of x as x approaches 1 from the left. 1 from either side. 1, very good. G of 1, 3. Limit of g of x as x approaches 2 from the left. 2 from the right. And 2 from either side. Correct. Questions? Is this better? Okay. So let's go again and just browse the material and you'll tell me stop. Okay. From chapter 2, you will have, again, some limits. The precise definition of the limit as an extra credit, maybe. Continuity, yes. And limits at infinity, horizontal asymptotes, and the derivative as a function that we just did, the first problem we did today. Chapter 3, derivatives and chain rule, implicit differentiation that we looked at last time, logarithmic differentiation that we did today, related rates that we did last time.
Did we ever do a chain rule last time?
Oh, this was the chain rule.
Oh, yeah, it's true. We did.
This is the chain rule, right? So every time I say the top prime times the inner function prime, every time I say that is the chain rule.
That's true.
So we did related rates and then linear approximations and differentials that we did last time. The square root of 99 or something like that. Chapter 4, mean value theorem that we did today. L'Hopital's rule, graphing and Newton's method that we did last time. And chapter 5, integrals, fundamental theorem of calculus that we just had, substitution rule. What would you like me to go back to?